Hey everyone, it's Jared Pistol here making another video for Simpson Math at Temple College. Today, this video is going to be made from one of the questions from the exponential and logarithms major assignment. And we're going to be going over part 1. And I'm going to show you guys what that is in just a second. And we're going to get right into it. So I've already done question 1. I've already have it written out here, so I'm just going to be a little bit more brief than in my last video. Do a little bit more explaining, less basic understanding, because you should have already taken a look at the notes before we start this. If you haven't taken a look at lecture 19, exponential functions, you're going to want to go ahead and take a look at that before we delve into this. So, alrighty. So number 1 is going to be given f of x equals 1/2 with an exponent of x minus 3. Perform the following tasks. So the first thing we got to do is we got to state the equation of the parent function of f of x. And if we look in the notes, we see that one of the new parent functions that we've learned is g of x is equivalent to 1/2 with an exponent of x. And that's what this looks most, this is the parent function that this looks the most like. And so the parent function is, so the parent function of this particular problem is going to be the f of x equals 1/2 to the xth. So for number B, we're going to state the transformation. So what makes this new function different from the parent function? And if we take a look at that exponent right there, that 3 is right next to the x, and you know, if the value right next to the x that's affecting the function is less than, or sorry, if it's since it's -3, we know that we gotta shift to the right 3 units. Now there's nothing else different from the function that we were given and this function right here, and so as a result, that's the only translation. That's the only transformation we have, is shifting to the right 3 units. Now, letter C is we're going to find and plot at least 5 points. As you can see, I plugged in 7. I was originally planning on plugging in 5, but when I started doing -2 and -1, I realized that the y values were a little too high for me to want to put that down on a graph. I don't want to make a graph that's 32 units high. So I actually started. So the plots that are actually going to end up on my graph are the ones that start actually at the y-intercept, which is going to be 0, 8. If we look at it there, we have 0, and we just plug in 0 for that x, 1/2 to, well, if you do the math for that exponent real quick, you end up with 1/2 to the -3rd, and that ends up being 8. For 1, you end up having 1/2 to the -2, that ends up being 4. Plug in 2 for x, you end up getting 2. Plug in 3 for x, you end up getting 1. Plug in 4 for x, you end up getting 1/2. And it's just going to keep on dividing. So the further we go down here, the more this is just going to get smaller and smaller, but we're never going to quite reach 0, as we're going to see in just a second. So part D is we got to find the y-intercept. We did that by plugging in the x value right there of 0 and getting 8 as the y value. So 8 is going to be, or sorry, our y-intercept is going to be 0, 8, as found in part C. Now, for E, it says state the horizontal asymptote, and in the notes, we learn that whichever number the y values are going to as x approaches infinity is where that horizontal value is going to be. So as x approaches infinity, y approaches 0, but never gets quite to it. And so the function 1/2 to the x minus 3rd has a horizontal asymptote at y equals 0. We're going to state the domain and range. The domain, I don't see a problem with, and we're gonna see when we graph it, or when I show you the way I graphed it, we're gonna see that there's not a problem with x reaching negative infinity and all the way to positive infinity. And so the domain is going to be all real numbers. Now, since the horizontal asymptote is at 0, our range is going to be all values of y such that y is greater than 0. So just remember that. That horizontal asymptote kind of dictates how big those y's can get. And so you got to make sure that you're careful with that. Part G is now we're actually asked to graph this thing. Sorry, let me turn that page. As you can see, we labeled all those plots that we got in part B. We got the y-intercept at 0, 8, and as it continues moving 1 unit over horizontally, the y value continues to half. So we got 0, 8, 1, 4, 2, 2, 3, 1, 4, 1 half, and if I went all the way to 5, it would actually end up being 5, 1 fourth, then it would be 6, 1 eighth, 7, and we would just be getting closer and closer to 0, but never quite 0, and that's why I've drawn that horizontal asymptote. It's kind of those thicker dashes along the x-axis. So, part H is they asked us to use the properties of exponents to rewrite the function of x into an equivalent function and name it g of x. And since there are several possible equivalent functions, the one I decided to go with was, and I'm going to show you guys this from the section of the notes, is I decided to go with the power of a quotient property, which is if you have a fraction that has an exponent, then that means that you can rewrite it with the numerator and denominator having the same exponent. So I went and took f of x equals 1/2 x to the third, and I rewrote that saying g of x equals 1 to the x minus third over 2 to the x minus third. And in I, it asks us to prove it and make sure that that is indeed the same function. Well, if we look at the translations, since it's the same exponent in the numerator and the denominator, you can go ahead and turn it back into this in your head through the power of a quotient property, because they do share the same exponent, and you can just tell right there that that minus 3 is going to translate it to the right. That's the only translation that we have in this new function as well. And if we plug in all of our x values into the new equation, we will get the same answers all the way down.